Alright, in this video we're going to take a look at a couple of things having to do with some of the math questions that are in the general license level. So bear with me on that. We're going to talk a little bit about what RMS is and peak to peak and why they're important, and more importantly, at least to me, where some of these magic cookie numbers come from. I've put up here a couple of formulas that are being used, and you'll notice that they have 0.707 and 1.414. Where do those come from? Why are they there? Why is this important? And so we're going to talk a little bit about that. Okay. Now, let's take a look at the anatomy of a sine wave here, and let's start with this circle. This is referred to as a unit circle because the radius is of length 1. Whatever the units are, it's 1 unit. Okay, from the center out to the edge. And we start here with it flat on the x-axis at 0 degrees, and it rotates backwards, and as it goes through all 360 degrees, if we were to plot those points, it would create a sine wave. And I like this particular graph because they show it with the radius here being at 45 degrees, which is kind of an interesting thing. All right, so let's find out a little bit more about what that's about. I come down here and we get a line here. Okay. I didn't get that perfect, but it's close enough. We have a triangle. Okay, and notice that this is a triangle up here. And this is a triangle that I have created such that both the x and y axes are the same, and we're going to say that this is 1 unit and this is 1 unit. And we want to be able to determine the length of the hypotenuse here, and so we can use the Pythagorean theorem, and that says then that the hypotenuse is equal to the square root of the square of the two sides. So we have 1 square plus 1 square. And so we see then that this is equal to the square root of 2. So the length of this is the square root of 2. So this is where the square root of 2 pops up its head and comes into play here. If we do the square root of 2 on the calculator here, it is an irrational number, and I believe it's a non-repeating decimal number. Anyway, let's convert it to a decimal. Notice that the square root of 2 is approximately equal to 1.414. And if we knock that puppy in half, we get our 0.707. So this is the origin of these magic cookie numbers. Okay, so they come with, because of the association with 45 degrees here, and the sine of that value and half the sine of that value. Okay, so let's pop up another picture here. And let's do, not that one. Yeah, let's do this one. And it's a little bit distorted. So I'll shrink it down in size here a little bit. It doesn't need to be that big. Okay. All right. Notice now on this graph that if we were to continue this line down, we see here that this would be halfway between 0 and 90. So this is our 45 degrees here. And this is exactly at this point where we measure the voltage of RMS. RMS means root mean square, and it's a statistical way of calculating things. We don't care about that, but it happens to be half the square root of 2. And it appears over here as well, and this would be at 135 degrees. And right here, if we came down, we would see that. Now, what does this have to do with anything? Why is this point even important? Well, if we were to, it's unfortunate they didn't do it on both the bottom half, but you would get the same thing here. So, 0.707 up here and here at these would also be the RMS value. What's important here is to notice the shape of the curve between here and where it occurs again down here. I learned about this many years ago. I was working in a high-end audio shop as a technician fixing amplifiers, and the idea was sound is to be able to transmit sound and its power, of course, through an amplifier so that there is very little distortion. We don't want to hear distortion in the sound. Well, anything above and around this peak is distortion. And it's no different in amateur radio. That's why RMS power is the important part. This is linear. It's almost a straight line. This gives the cleanest sound, the cleanest signal. This is the type of power that's important. There used to be power wars, I guess, among the various manufacturers of audio power amps. And yeah, well, we offer 80 watts per channel, and I'll put down in parentheses or small print that that's peak to peak. So that includes the full thing here, but that's not the power that's being used by the amplifier, because the amplifier filters this off. Doesn't use that. It only wants to amplify the most linear part of the curve. So really good brand named audio amplifiers didn't try to fool the public with a peak-to-peak value just because it was higher. They would say that their true power would be like 37, I don't know what I'm just making that up, 37 watts per channel of true or RMS power. This is the actual power you would hear. This is a much better value than this value. Here they're trying to fake you into thinking, well, higher has to be better. Well, only if you want some distortion in your signal. Okay, so that's the reason for wanting to know the RMS value and why that's important, and that it's calculated from where the angle is at 45 degrees and multiples of 45 degrees throughout the whole 360 degree movement of the sine wave. Because this is what we really want, right here, this sweet spot in between. And then, of course, we see the voltage peak to peak. So we get voltage peak to peak, and that's sort of related to the peak envelope power. That's another calculation that they deal with. And then just peak voltage is from the 0 point where the signal is finished its positive transition, getting ready to go negative. That's from the 0 line to wherever the peak is. So that's the other voltage for peak. And that all ties in with these values. Okay, so with that as kind of an understanding, we will get into working some problems where we are calculating these various values. But this is where they come from, and this is the origin of those magic cookie numbers. It all has to do with the square root of 2 and half the square root of 2. That's where those numbers come from, and that's related to the 45 degrees because that's what marks the sweet spot on the sine wave. At 45 degrees, the multiples of 45 degrees. All right, hope that clears up some mystery.